Hello everyone. So in today's video of chapter Basic Analytical Techniques, I'm going to talk about simple distillation, fractional distillation and solvent extraction. Distillation is an important method which used to separate volatile liquids from non-volatile impurities and liquids having sufficient difference in their boiling points. We used to purify such liquids which boil without decomposition at atmospheric pressure with simple distillation method. In this process, the liquid will be first converted into vapor by boiling, and then vapor will be condensed back into the liquid by cooling process, and pure liquid will be collected in receiver flask. Apparatus, as you see on the screen, it is a round bottom flask containing a liquid which is going to be purified, and a flask has a side arm through which it is connected to the condenser. Then the condenser has a jacket with two outlets through which water is circulated. The liquid is to be distillated in round bottom flask and it is fixed by clamp. The flask is placed on water bath or oil bath depending upon its boiling point. The condenser is connected to the receiver to collect the purified liquid. Care is taken that the bulb of thermometer is just below the side arm, like that you are seeing on the screen of the round bottom flask. Now the flask will be heated. As the boiling point of liquid is reached, it will start boiling and the vapor will rise to the neck of the flask and pass through the side arm into the condenser, which is kept cool by circulating water from the jacket or through its jacket. The vapors condenses and the liquid is collected in the receiver flask. This is how the distillation used to happen for purifying any liquid. Now, fractional distillation. If in a mixture the difference in boiling points of two liquids is not appreciable, they cannot be separated from each other using simple distillation process. To separate such liquids, the process which is used is called as fractional distillation. In the apparatus for fractional distillation process, the distillation flask, which is this flask, is assembled with fractionating column. Vapors of more volatile liquid with low boiling point rise up more than the vapors of the liquid having higher boiling point liquid. Then the vapors will be condensed here with the help of condenser and collected in the receiver flask. Let's suppose we have two liquids, liquid A and liquid B. We have taken both the liquids in round bottom flask and A liquid is more volatile than B liquid. So the mixture will be heated. Vapors of A along with the little vapors of B will rise up and come in a contact with the large surface of fractionating column. Vapors B will condense rapidly and come back to distillation flask, whereas vapors of A will move and get condensed into the condenser and cool down and collected in the receiver flask. Rising vapors become richer in A and escape through the fractionating column and reach into the condenser, while the liquid in the distillation flask is richer in B. What I am saying, I am repeating here. The liquid A will be collected in the receiver flask and liquid B will remain in the round bottom flask through this process. Mixture like acetone and methyl alcohol can be purified by fractional distillation method. and acetone and benzene could also be separated by this method. Now, distillation under reduced pressure. Liquids having high boiling point, or those liquids which used to decompose on heating, are purified by carrying out distillation under reduced pressure. In this method, the liquid is made to boil at the temperature which is below at its normal boiling point by reducing pressure on the surface of liquid. And in this process, pressure is generally reduced by using water pump or vacuum pump. In soap industry, glycerol is separated from soap by using this technique. So I am repeating here, all those liquids which used to decompose on their boiling point are purified by distillation under reduced pressure. Now, solvent extraction. When an organic substance is present in an aqueous solution, it can be extracted from that solution by shaking it with an organic solvent in which the substance is more soluble. The organic liquid should be immiscible with water and be able to form two layers. In this process, the solute distributes itself into two immiscible liquids from the aqueous phase of the solid and get extracted in the organic phase. Extraction of compound takes place based in the difference in the solubility in the two liquids, as you are seeing in the figure. On shaking for fewer times with small volume of organic phase, most of the solute get extracted into the organic phase and the organic solvent is then removed and solute is collected. The solvent extraction process is important as it helps clean separation in short time. If the solute is less soluble in organic phase, then the technique is called continuous extraction. Whereas where the same amount of organic solvent is used repeatedly for extraction, this technique involves continuous distillation of solvent within the same assembly. Thus, use of large quantity of organic solvent is avoided. So, this is solvent extraction process by which we used to separate organic substance.